Hello everyone, and so today we'll just solve some of the problems related to last week. Yeah, one second. Are you able to hear me? Like, can somebody can unmute yourself?
Yes, sir. We are able to hear you.
Okay. So yeah, I'll share my screen now. So you can join from here, joinpd.com, and then you can type this code. You'll be able to join. So everybody, please join this. Yeah, everyone please join. It will help you to solve the question in the final exam also, and the graded also you can able to solve all the problem. So so we are having 50 participants now, but only 8 of them has joined. So please join us ASAP. So after solving these problems, like we'll be having 10 to 12 problems. Then if you're having any doubts, you can ask me also related to last like 2-3 weeks. Okay, then I'll start. We are having like 14 students have joined till now. Okay, I'll start now. If anybody wants to join, like you can just go to that joinpd.com and then you can write this code IBINBI, all the small letters, and you'll be able to join. So I'll start this now. This is the like you have seen this question, I guess, everywhere. So this is pretty simple one. You'll be able to solve. Just try it. I'll give you 1 minute or 2 minutes to solve this. Just you have to use the Chebyshev and you have to solve. So this has been there in the graded also, in the practice also. So just have to calculate the upper bound, but the P, alpha, and N is changed here. So you can do it. It's a pretty simple one. You already have solved so many times this type of problem. So I don't think so there will be any issue. And yeah, so just try to solve all the problems, whatever I'm providing you. You'll be able to solve the question in the final exam also, or the graded also from the last week. And if, yeah. So this question you have already done so many, like 2 3 times. So why it's taking time? It's pretty simple. So we have got 6 responses till now, and Chebyshev you have to use. It's already mentioned in the problem that, okay, it's not mentioned. Yeah, it's mentioned using Chebyshev inequality. So we have 7 responses. So yeah. So point 5 is the correct one, and so it will come like, if you'll solve, you'll get the values in the form of like n upon, sorry, yeah, 4 upon n, some sort of things, and there you'll put the value of n, you'll get point 5. So I'll solve the question. Does anybody has any issue? Should I solve or it is fine? We will solve this. Yeah, we'll solve this one. So this is the first one, and we have to calculate the probability such that x is greater than alpha n, right? And we have been given, so this can be written like this, right? So the probability of x minus alpha p greater than, greater than alpha n minus alpha p, right? And this is less than equals to what? Variance of x upon alpha n minus alpha p ka whole square.
So why did you do alpha p? It should be NP, right?
Yeah, sorry, np. Yeah, it should be np. It's a mistake. So here it will be alpha n minus np ka whole square. Okay. So this you can write it like variance of x is what? Np cube, right? And from here n square will come. So alpha minus p ka whole square. And that will be less than equals to n will get cancelled. So pq upon n alpha minus q ka whole square. So now you'll see what's the value of p, and q is p has been given as 1 upon 2. So q will also be 1 upon 2 as 1 minus p. N is given as 8 and alpha. Yeah, so n is 8. Alpha is 3 upon 4 minus 1 upon 2 ka whole square. So this you'll calculate, you'll get around less than 0.5. Okay. So this was the first question. Uh, yeah. So is that fine? Everybody has got that, right? This was a simple problem. So we'll move to the next one. This is also already most of you have done, but it's just of a, what you can say, sort of revision sort of thing. So you'll be getting not the same type, but a bit difficult type of question, but on the same platform. Like this type of question only you'll get from last week, but a bit difficult, you can say. Yeah. So this is the second one. You have been given regarding the normal distribution, normal vector and all. It's a Chebyshev equation. Yeah, Chebyshev we are using the last one. And yeah, so this is the second one. So here y is a vector, is having y1 and y2 as a two different, like you can say, vector. Mu is the mean for y1 and y2, and this is the variance matrix. So y is generally a combination of two normal distribution. Okay. So why somebody has given C as option? C can't be, right? Okay, okay, fine. We'll calculate. So C, yeah, C can't be the answer. So this was like this. I don't think so. Anybody will be having any issue in this. So here, if you have to calculate the distribution of y1, that means you need the mean or the expected value of y1 and the variance regarding y1. Okay. So the mean here is what? For y1, the mean is what? 3. So 3, then the option B and D got like rejected, or you can say excluded. And now we have to see the variance. So the variance of y1 will be what? 6, because this is the matrix of this is the covariance matrix, right? And this covariance matrix consists 6 as the variance between covariance between y1 and y1 itself. So this is the variance of y1. Similarly, 13 is the, what you can say, the variance of y2 and y2. So these are variance for y2, and this is for the v1 y1 y2, and this is for the y2 y2. So both are same. That's why it's a symmetric matrix. Okay. So for the distribution of y1, we'll be having mean as 3 and the variance as 6. So 3 comma 6 is the correct one, right? So yeah, is it fine? So now you have to get the distribution of y3. Sorry, y2. So for y2, you have mean as 1 and the variance as 1, 3, right? So the 1 comma 13 will be the answer here. So B will be the answer for the y2. Okay. Yeah. And then we'll move to the next one, the the third one, fourth one. Here you have to calculate the distribution for z equals to y1 plus 3y2. Okay. So here you have C as what? C as a 1 cross 2 matrix. Okay. And having the value as 1 comma 3, right? So C, or you can say the A, Z, if you are able to write Z equals to A, Y. So here A is what? A is a matrix with 1 comma 3 as a value. Okay. 1 comma 3 is a 1 cross 2 matrix having values as 1 comma 3. So now you have to calculate the expected value of Z or G and the variance of G. Okay. That is what you have to calculate and you'll be able to get that. So, yeah. So here also, I don't think so there will be any issue because you have to do everything in the form of matrix. Okay. So expected value can be calculated like C or the A matrix into a whatever the mean value of y1 and y2 you can write, and similarly you can write it for the variance also. So you will get the value. I guess the A will be the correct option. So A, everybody has marked that also. I don't think so there will be any issue in that also. In the tutorial also the same type of question has been discussed.
So why can't we directly do it in the form of a linear equation like E of Z will be E of Y1 in plus 3 times of V of Y2. Similarly, V of Z will be V of Y1 plus 9 times of V of Y2.
No, that will not happen. See, expected value generally you calculate whenever there is a independent or dependent things, right? But the variance can't be done for the
Okay.
dependent things, right?
Yeah, okay.
That's why we generally
Yeah.
doesn't.
Yeah.
This is the next one. This is also simple. These are, I guess, the questions from the graded assignment. This is also a pretty simple one. These are based on Chebyshev. You have to use the Chebyshev inequality to solve this. So X is a non-negative number, a random variable with expected value as 60 and the standard deviation, the sigma is 5. So now you have to guess or you have to write about the upper bound of probability X greater than equals to 70. And you have to use the Chebyshev inequality to solve this. So this also, there is not much in this question, so I'll solve this one. So it will help you. So and you have to calculate the probability of x greater than equals to 70, right? So you have to use Chebyshev inequality with expectation. So this can be written like this: probability of x. This is how you can write x minus 60 greater than equals to 10 should be less than equals to what?
Variance of x by 10 square.
Yeah, so variance of sigma square upon 10 square. That will be sigma is what?
25.
25 upon 100. So that is less than equals to 0.4. Okay.
0.25.
Sorry, 0.1 upon 4. Yeah. 0.25. Now the next one is the shopkeeper generally sells a LED and the expected demand for the LED is 4 per week. Now based on the given information, choose the correct one regarding the random variable x. So the first equation generally tells what is the probability of selling the material like the LED greater than 10, the 10 more than 10 piece is greater than equals to 0.4. The B is less than equals to 0.4 and the probability of x less than 10 is greater than equals to 0.4 and less than 10 is less than equals to 0.4. So these are pretty simple. You can use directly the Markup's inequality here and you can write it the expected value is 4 and we have to divide it with the t and here the t is 10, right? So we can directly write 4 upon 10. So B is the correct option because probability of x greater than equals to t should be less than equals to expected value of the expected number of the product sold upon the t value, that is the 4 upon 10. So B is the correct one. So here you have to calculate the probability of getting the tail while tossing an unfair coin is 0.4. Now suppose that coin has been tossed 30 times. Find the upper bound using the Markup's inequality for the probability that it lands on tail at least 20 times. So here also you have to use the Markup's inequality and the mean value you can calculate directly because the probability has been given and the number of times the coin has been flipped is also given. So the mean value would be 13 to 0.4 and you have to get the bound for at least 20. So it should be greater than equals to 20 and the probability would be less than equals to expected value, that is expected value is 12 upon 20. So 12 upon 20 is what? 0.6. So 0.6 should be the value. So 0.6 should be the correct answer. Okay. So any issue in that? It's a pretty simple one. So the next question will move to the next one. So suppose the coin toss is flipped 200 times. Find the upper bound for the probability that the number of times the coin land on head is at least 30 or at most 70. So here you have to use the Chebyshev inequality, but the other one, like you generally have to no, you have to use the, like, you should be having in the mind both the Chebyshev inequality to solve any of the problem. Here, not the other one. You can directly solve with the simpler one. Generally, what we write in the Chebyshev inequality, you don't have to use the other one. The other one is simply the 1 minus 1 upon k square. So here you can directly use the basic Chebyshev inequality and can solve this problem. So this type of question you can get it in the exam. That will generally where you get a bit confused which Chebyshev inequality you have to use. Okay. So this, please everyone solve this problem, and I'll wait for like a bit 2 minutes. Until now, if you're having any issue, you can ask. Most of the questions are from Chebyshev and Markup's inequality and the MLE one. So we can get most of the question around like Markup, Chebyshev, or the maximum likelihood estimation sort of things. Because the problem, the like clustering model, we can't give a problem that is solvable with the hand. Okay, it will take again a lot of time, so we can't give the problem on GMA model. But if you have any conceptual issue regarding that, you can ask me after. Like it will more like 25 minutes it will take to solve all the problem. Then we can discuss if you're having any problem in clustering model and all sort of things. So yeah, this one please solve everyone. This is a bit like confusion, will create a bit confusion. This type of question you can get in the exam. So please solve this one. Has everyone tried this one? The answer would be approximately 1 upon 18. So 1 upon 18 means 0.05. Okay. So I'll solve this one. So everybody has tried this question. Like I've got only 4 responses.
So could you please do this? I haven't got the answer.
Okay. So yeah. So we are flipping the coin 200 times, right? So now we have to get the upper bound for the provided that the number of times the coin lands on head is at least 130 and at most 70 using Chebyshev. Okay. So see, this is generally the normal distribution, right? Okay. And this is what, this is mu, and this is mu plus k sigma. This mu minus k sigma, right? So in this question, they have asked that the number of times the coin lands on head is at least 130. So it should be greater than 130. So we can assume this as 130. So greater than this and less than and at most 70 means maximum 70 means it should land here. So either it can land here or it can land here. So this is 70, right? And this is simply the Chebyshev inequality, right? This is the Chebyshev inequality. This is what probability of that mod x greater than equals to q sigma less than equals to 1 upon k sigma, right? So this is the Chebyshev inequality. The probability that x is greater than k sigma, or this can be written in both the form, like the probability of this area plus probability of this area should be less than equals to 1 upon k square, right? So this equation is what? Mu minus k sigma is 130. Sorry, mu plus k sigma. And mu minus k sigma is what? 70. So this can be solved. Like we already have mu. So mu is what? Mu can be calculated, right? So mu is what? NQ. And the number of times we have tossing is 200 times, and it's a fair coin because it's already been given regarding the coin. It's a fair coin. So we have mean as 100. So k sigma is what? 30. Sigma can also be calculated. Sigma is generally NQP, right? NQ, sigma square is NPQ. So sigma is NQP. Under root NPQ. So we'll be having root 50, right? Because 100 upon 20 will be root 50. So K will be what? 30 upon root 50. Okay. And in the Chebyshev inequality, now we can write it 1 upon K square. That is 30 into 30 upon 50. So this will get cancelled. So we'll be having what? This is 6. So 1 upon 80. Is it fine?
Yes, sir. Thank you.
So we'll move to the next one.
So I have one doubt in this.
Yeah.
So I didn't solve it like this. I just solved that if one side is 130, so anything over 130 would be the variance by t square.
Yeah.
Okay. So for me, that was coming to 30. 30 was the t square, 30 square, and variance was coming to 200 into 0.5 into 0.5.
50. Sorry, 50.
Right.
And
So then I
multiplied.
multiplied by 2 because I'm
Okay.
taking both sides. I'm taking less than 70 also and greater than 130. So I'm getting double of what I'm getting 0.11. So there's something wrong which I'm doing.
See, what? How much you have got?
So with one side, I'll get what you got this answer 0.055. But I multiplied by 2 because I'm taking the other side also, which is less than 70.
Yeah, but see, that is also, I guess, correct. But the one thing is,
But sir, do you need to multiply by 2 because it's mod already taken, right?
no. He's asking. He had just calculated for one area, and then he's multiplying with 2, right?
Right, sir.
So, but when we are taking mod, doesn't it cater to both the things? It doesn't, is it?
Yeah. It take both the things. That's why we are writing. If we'll open this one, this mod, it will be like probability of x greater than mu plus k sigma plus probability of x less than mu minus k sigma.
Yeah. So is that multiplied by 2 required?
No, it's not required in the case.
I'm taking one side, so I'm multiplying by 2. So that's what I've done.
Okay.
But why is my answer not matching?
Yeah. So what you have to, you are just using Markup's inequality, right?
Right.
So you are writing what? X greater than 130.
Right.
So if you write 130, so here it will come 130.
X minus 100, right? X minus 100 greater than 30.
X minus 100
greater than 30 equals.
But Markups generally work like this, right? If you're having x greater than t, then expected value.
Okay,
This is
yeah,
expected value.
Yeah,
First of all, so you are taking again variance. So you are just mixing both the things, half of
Okay.
Markups and half of Chebyshev.
Okay. Yeah, I got my mistakes. Thank you. Thank you.
So, but what's the answer for this, sir?
1/80.
1/80. Okay.
Right, because we were getting k as 30/√50 and 1/k. So Chebyshev inequality you can write in 2-3 ways, right? So I'll just write it in a graphical way. So in just if you are able to visualize it, you'll be able to solve this mu, right? This is mu plus k sigma, and this will be mu minus k sigma. So if somebody is asking regarding this area, okay, so this you can write in the form of Chebyshev as less than equals to 1/k square. But if somebody is asking regarding this area, then you have to write it what? Greater than equals to 1 minus 1/k square. Have you got like this one?
Yes, sir. This is the lower bound or what?
This is the lower bound. This is the upper, like not the lower bound. This equation is regarding that upper bound.
Okay.
Because this is less than equals to 1/k square. So this will work as the upper bound.
Right.
And this will work as a lower bound because this is greater than equals to 1 minus 1/k square.
Okay.
So this type of, yeah.
But this is actually, technically speaking, it's the area between mu minus k.
Yeah, this is simply the area because we are calculating probability and this is the CDF, PDF. So we are calculating the area only.
Yeah, but why is it called lower bound, sir? Because it's actually between mu minus k sigma and mu.
Yeah, it's called lower bound because the maximum value of the probability can go till here.
Okay.
But
that term is a little confusing. Yeah, but now it's clear. Okay. Thank you.
Yeah.
Vivek sir, I would like to add to your doubt. You would get that answer correctly if you didn't multiply by 2 and keep the mod as it is. Because when you say 130 and 70, it is, I mean, it falls 30 range between 30 across 100.
Cross, right. Got it.
Yeah. So if you hadn't multiplied 2, I tried that actually. You get it.
Yeah, I multiplied by 2. I made the mistake.
Yeah.
Thanks.
Okay. So we'll move to the next one. This is a bit more confusing. Here mu is 80, standard deviation is 6, and AB you have to calculate. And it's been given to find the interval AB about the mean mu equals to 80, for which the probability that X lies in the interval is at least 99%. The probability the area is at least 99%. Now you have to calculate the AB. So if the visual, like if you are just plot the picture, you'll be able to get it, I guess. So just write the mu minus k sigma as A and other side as B, and then you'll be able to solve this. So if somebody in this same question, if somebody is asking A plus B, so A plus B, can somebody tell directly what would be the A plus B value? Directly without calculating A and B, because
160.
Yeah, that will be 160. Yeah, correct. Because of the symmetric, because it's a normal distribution, so it will be like double of that mean value, right? So first give me the value of A. Okay, and then you can write B. So first give me the value of A. So mostly you have to calculate the value of K here. And which equation you have to use, that you have to think which Chebyshev inequality you have to use. So here you have to use the Chebyshev, that you would have like till now you'd be clear how you can use the like which equation you have to use, because with markups you won't be able to do this. So you have to use the Chebyshev, but with Chebyshev equation you have to use, because it's an interval sort of thing. So you have to use the other Chebyshev inequality. Till now we have not discussed here. So you have to use that other Chebyshev inequality, and you have to get the value of K for that, and then you'll be able to do this A and B. So first write the value of A. I guess nobody has written the value of A correctly. Only one has written the correct. See, in the Chebyshev inequality, every time we use at most, right? But here it's given at least. At least means greater than equals to 99%. So it should include greater than equals to 99% of the area. So for that, generally we use the other Chebyshev inequality, because for the Chebyshev inequality we generally use, there we generally talk about the area is less than equals to, means the area is at most that much. But here we are talking about at least. At least means the area should be greater than equals to 99%, right? Are you able to do this, or should I solve? Because only one student has given the correct value of A.
So can you please solve? I'm not getting.
Okay, I'll do this. So yeah, so here it has been given X is a random variable with mean 80 and standard deviation is 6. Now you find that you have to get the value of A and B, right? So that the probability for which the that X lies in the interval is at least 99%. Okay. So if we'll plot this normal distribution again, right? So what happened here? This mu and this mu is 80. This would be A, right? And this would be B. And the area inside AB should be at least 99%. This area. So every time what we were talking, every time we were talking about this area and this area, right? In the Chebyshev. And in that calculating this area and this area. we were getting the equation sort of things like 1 minus k square, like the probability such that x minus mu less than k sigma is what? 1 upon k square, right? But here we have to calculate the area of this interval, this area. And this area should be greater than equals to 99%, right? That means what? The probability such that the x less than a and b is greater than equals to 99%, means 0 point, as the area is 1. So it should be greater than equals to 0.99, right? And this can be equated as what? 1 minus k square, 1 minus 1 upon k square, right? So this, if you will equate both the equation, 1 minus 1 upon k square equals to 0.09, 0.99. So this you will get as what? K you will get as 1 upon k square, you get 0.01, and k you will get as 10, right? Yeah. So now you are having the k, okay? So, and this is what a you can directly write as mu minus k sigma, and this is mu plus k sigma, right? So you have already the value of mu. So mu would be what? Mu is 80 minus k is 10 and sigma is 6, right? So here 80 plus 10 into 6. So this is 20 and this is 140, right? So the A will be 20 and the B will be 140. And how we directly say A plus B, sorry, and B, A plus B, because one will contain K sigma and one will contain the minus K sigma. So A plus B will always be 2 new. So that is 160. So I guess this is clear, right? Now,
Yes, sir.
So for the end terms, will there be a formula sheet like we had in stats 2?
yeah, the formula sits in there.
Okay, sir.
Yeah, this
These
is the
inequalities will be there in that.
Chebyshev inequality will be there.
Not in all the forms, right, sir? Any one inequality.
Yeah, any one equation.
Yeah.
The other you can get from the book, right?
Yes, sir.
This is the second last, I guess, the second last or the third last question. This is on the MLE, but for the exponential distribution. So one thing for the like for 2-3 distribution, you should be knowing regarding the MLE how to do that. Like for the exponential, for the Poisson, for the normal distribution, you should be knowing how to like get the parameter estimated value. Like for the, if that is a Poisson distribution, you should be able to know what the value of lambda. Okay, and if this is an exponential, you should be knowing regarding the lambda, how to get the lambda, and what the estimated value using ML. Okay, and if you are having the normal distribution, so you should be knowing if one thing is constant, what would be the estimated value of the other thing. Like if mu is constant, what would be the value of sigma square, and if sigma square is constant, what would be the value of mu for the normal estimate, like for the estimated value using ML. Okay, so only for the ML you should be knowing, not for the any other estimates and like for moment generating and all. There are many other methods to estimate the value, but only you have to read regarding the ML. Okay, because this is one of the accurate, you can say, the estimator. Maybe you'll read in the next, or you'd have read regarding the moment generating functions and Bayesian estimation and all. But here you'll be only asked about the ML. So you should be knowing regarding the lambda of the Poisson for the exponential and for the normal distribution. These are three important ones, can be asked in the exam. So this is clear, like you are able to do this, right? So there is no issue in that. Or should I solve this one? Does anybody wants to solve like me to solve this, or should I skip this? Because it's you just have to write the likelihood function. If you don't know regarding the lambda, the estimated value of lambda using MLE for the exponential distribution, you can directly write the likelihood function, differentiate it, like take the log, differentiate it, and you will get the value of estimated. You will get the estimated value for lambda, and then you can use all those values. Will be able to do this, right? So everybody has given the correct answer. So I'll move forward. Or does anybody wants me to solve this? So I'll solve.
Sir, it would be good if you can solve this, sir. And
Okay.
sir, would those CDF, PDF functions be given in the exam, or should we remember all of them?
CDF PDF function, I guess. I'll show the one. I guess
Sir, is it possible to get the formula sheet before in hand, because we can know which are all coming, and
so the formulas, it will be same as the stats one.
same that will be there? Okay.
Yeah, so everything is there, right? The PMF, CMF for the geometric.
Yeah, yeah.
So it's already
It's the
there.
same thing, sir, which we used to get for stats.
Yeah, the same thing, because everything is same, right? So we are not include anything, not exclude anything, right?
Okay, sir.
Okay. So this will be the formula should be it. And yeah. So I'll solve this one. Okay, so for the exponential, if you don't know regarding the estimated value of lambda for the exponential, so what you can do, you have to write the likelihood function, right? So for the likelihood function, how you'll write, because this is a family of exponential distribution. So for the family of exponential distribution, you write generally lambda e to the power minus lambda x1, right? This for the first data point. Similarly, for the second data point, you can write minus lambda x2, right? Similarly, you can write for the n data points, right? Now, if you will take the log of n, so you will be what? So this all will be multiplied n times, and this will get summed up. This will be the summation of all the x, right? So if we will take log both the side, what will happen? It will be n log lambda minus lambda summation of xi, right? If you'll now you have to differentiate it with respect to lambda. So you'll get what? N upon lambda minus summation of xi. This will equate it to 0. You'll get lambda as what? N lambda equals to summation of xi, and you'll get lambda as n upon summation of xi. So n is what? N is how much? 1, 2, 3, 4, 5, right? So 5 upon, so the summation of all the values. So summation is what? 3 upon 4 upon plus 2. So 3 plus 4 is 6, 2, 8, 6, 14 plus 5, 19 or what? How much?
20.
Okay, 20. So you'll get around 0.25. Okay. So
Sir, could you show that calculation again, sir? Just a minute.
here, so this is the likelihood function.
Sir, with the summation of xi, there is a lambda as well, right, sir? Lambda xi.
Where?
In the third line, sir. So
Yeah,
when we
lambda,
come down, that becomes.
we'll differentiate with respect to lambda.
Oh, okay, sir. So that's the mistake that I did. Yeah. Thank you, sir.
Okay, so that's it. We'll move to the next one. This is also then will be the Chebyshev. Yeah, this is also simple. So 3 more problems are there. All are Chebyshev inequality. So this is what the find. You have to find a bound to probability that the function x is at least 1 standard deviation away from its mean value. Okay, so if you are having some like that normal distribution, So it should be 1. Like here the k value is what? So 1 standard deviation means k value is 1, right? So that it should be greater than equals what? Less than equals to 1 upon k square. So k is 1, then it should be less than equals to 1, right? Have you got, like, everybody got the point? Like if you have to calculate the bound, so it should be 1 standard deviation away. 1 standard deviation means the k value would be 1. Okay, and I'm talking about this equation. Sorry, greater than equals to k sigma is less than equals to 1 upon k square. So it's one step or one, what you can say, the mu value is one step away from the standard deviation. Talking means the k value would be 1, so it should be greater than equals to 1 upon 1 chi square, so less than equals to 1. This is what has been asked. This is pretty simple. Yeah. And the next is also Chebyshev inequality, or the distribution of the certain companies employee monthly salary. The mean value is given, the standard deviation is given. Standard deviation is sigma, and it's been given here. Okay, and the probability that the randomly selected employee had to be greater than, like, has a salary either greater than equals to 1 lakh or less than equals to. So again, you have to calculate the area. So just remember this plot only every time. If you have been given this plot, so greater than some area and less than something, right? So sorry, less than this, less than some constant value, so that you can equate it with mu minus k sigma and equate this value to mu plus k sigma. Get the mu value, mu and k will always be given. Get the k value, and you can directly get the less than equals to k square as the final value. So there won't be any problem in solving this also. If you are having any issue, you can ask. So, but this is also pretty the same. We have been solving so many questions. And the last one is also the same, but here you have to use the Markup inequality. And here is what has been given: the number of people who make a reservation in a reservation in a restaurant a day in a random variable. Mean is been given, the variance is also been given. So you don't need the variance because here the Markup inequality has been asked and should exceed 40. That means the t value is 40 here and it should be less than equals to what? The mean upon 40. So 15 upon 40. That is the final, what you can say, answer.
So can you give the answers of 12 and 13?
Which one? Last one.
The last one.
The last answer would be the less than equals to, I guess, what k value will be what? 2, right? So 1 upon 2
Okay.
chi square. So 0.24.
Okay.
Okay. So this is the last one. You have to use the Markup's inequality, and here the expected value is 15, and that one is 40. So 15 upon 40 will be the final value. Yeah. So this was it from the, like, 12th week is mostly, if somebody is asking you the problem solving a question can be from the MLE, can be from the bounded inequalities, and mostly they can ask regarding the distribution sort of thing. Nobody can ask you regarding the clustering, but you should be knowing regarding the clustering. That is the one thing. Because if I'll give you the question regarding the clustering, it won't be able to, like, manually, it's very difficult to solve that. Okay, but you should be knowing regarding the clustering thing. That is the one thing, because every time you'll be using, whenever you'll go and read that unsupervised learning, you will have to know regarding how that algorithm is working. Okay, that's the one thing. And yeah, so this was the question from the last week. So it's pretty simple. The final exam, same pattern of question will be there. So just try all, solve this all 13 question once again, solve the graded, like, more or less are almost on the same pattern, same base. So just clarify your doubt regarding the bounded inequalities and MLE sort of things. So you'll be able to do this. Okay, and now you're having any issue regarding the conceptual part, you can ask. So nobody is having any issue regarding these questions, right? If you're having, you can ask. I'll solve it now, because you won't be provided the solution for this. So you'll be having the questions, because I already have solved these all problems here itself. So I won't provide the solution for all this. So if you're having an issue, you can ask. If you want to know the answers, you need to write. You can ask that also. I'll solve it again and I'll give you the answer for all those questions. But please don't ask me the solution for all these questions.
Sir, hello, am I audible?
Yeah, you're audible, but voice is a bit low, but you can ask me. I'm able to hear you.
Sir, I want to ask from the activity question, I have a doubt regarding the calculation of variance. The first activity question, sir, from the first lecture. First lecture section 12.2.
Yeah.
So this question, so question number 4.
You have to calculate the variance. Okay, so variance, how generally you calculate the variance? If you're having Z is what? Z is in the form of CY, right? So this will be in the form of C square Y, right? So C square, you have to write in the form of C into Y into Y, C transpose. That is how you will be able to solve the matrix multiplication. Okay. See, this you will write it C into variance. C into variance of Y into C bar, right? So C is what? 2 minus 1 and 3, right? And the variance of matrix, the covariance matrix is what? 6, 1, 2, 6, 1, 2, 6, 1, 2, 1, 13, 4, and minus 2, 4, 4, right? And the transpose, you can write it like this, 2 minus 1, 3. Okay, so this is what? This is 1 cross 3, this is 3 cross 3, and this is 3 cross 3, 3 cross 1. So this will get reduced to 1 cross 1. So you'll get the value of variance of Z. Okay, so how you do, you can just multiply it like 2 into 12 is what? So if you'll multiply 1 cross 3 into 3 cross 3, you'll get 1 cross 3. Okay, so you should be getting 1 cross 3, so that you can multiply with 3 cross 1 and you'll get 1 cross 1. So this you will multiply 2 into 6 is 12, minus 1 is 11, minus 6 is 5. Okay, similarly 2 minus 13 is what? Minus 11 plus 12 is 1. 2 is into 2 is 4, minus 4 is 0, and then 12. If you multiply with minus 113, you'll get around what? 5 into 2 is 10, minus 1 plus 12 into 13.
It's 3. 12 into 3.
Okay, it's 3, sorry. So you'll get around what? You'll get around 36 plus 10, 45. Am I doing any mistake?
Sir, I think it's minus 2 in the math.
Where?
Yeah, so minus
First row, sir, 6, 1, 2.
Okay.
Minus.
Okay, so you can multiply 2 into 2 is minus 4, minus 4, minus 8 and 12 wins 4. Here it will be 4, not 12. So if you multiply, so here it will be 12. So 12 to 21. 21 is there, right? 21 is there.
Yes, sir. 21 is the correct answer.
Okay, so this is how you should be solving to calculate the variance. Yeah, somebody is asking something.
Sir, I have a doubt in graded week 11.
Okay, graded week 11. Where is that? So graded the time. Okay, 16 was the last. Okay, which question?
11. Question number 11. It's a marginal of fx. So
Okay, then what's the issue in this? You can calculate, like if you'll
Yeah.
you got the value
C
of,
we are getting as 1/8.
okay, so we have got C as 1/8, so xy upon 8, and we have to calculate what? We have to fix the value of x equals to 1, right?
Yeah.
And
But
I mean, yeah,
here it is, they're asking for marginal, right? Fx
Yeah.
of x means marginal of x. So we have to integrate only over y and we have to
Yeah.
substitute for x, right?
yeah,
So integration over y 1 to 3
1 to 3 you have to integrate dy.
dy. Yeah.
Okay, so what
So
you are
x
getting?
by 8 into x by
X.
y square.
16, 1 upon 13, 1 upon
Yeah.
3, and this you are getting what? X by 16, 9 minus 1, that is 8 upon 16. So what's the value is given?
8x by 16. Yeah. So when x equal to 1, it's 0.5, right?
Okay, yeah, okay,
Next one also it is wrong. 11 and 12.
okay. Yeah, 1 second. But nobody is, are we doing anything else? But
I searched in Discourse. I couldn't find any question related to this. So I thought I'll first ask here and then.
okay, but we need to, I'll 1 upon 8 is correct, or 1 upon 16 we are getting for C?
Yeah, there is a first question in that it is showing 0.125 as the value of C. First question is that what is the value of C? Seventh question. It's 0.125, that is 1/8.
Okay, I'll solve it. Oops. So X is from 1 to 2, right?
X is 0 to 2, Y is 1 to 3.
Okay, so C X square by 2, Y 0 to 2, right? So CY by 2 is 4. Now we have to integrate it from 1 to 3. So this is 2C, and then we have to integrate it from Y square to this we are putting as 2 get cancelled.
1 to 3.
Okay, 1, 3. So we are getting, yeah, so we are getting C as 1 upon 8. That is fine. These values are fine. This is also fine. But fx, okay, there can be a mistake. So, yeah, it's a mistake, I guess.
Because in the tutorial, if you see, the similar question has been solved, and there we integrate it with 0 to x also. So we integrate twice even for the marginal. So I also had this doubt at that time, because in stats we used to only integrate with respect to the other variable. But
So
if you
yeah,
see,
last week you said that the tutorial was wrong and you want to correct it, right?
Oh, okay. Okay. I didn't know that.
Last week I asked the question, so Vishal sir said that is wrong.
This
Okay.
answer should be 0.5 only. It's 11.
Yeah. Yeah, it should be 0.5 only.
And can you please show that 13 also? I'm not sure how to solve that. Is it
13 you have to integrate it from like 0 to
twice,
that,
right? 0
yeah,
to 1 and
that y should
1
be
to
from
3.
3 because y can't take 4.
Yeah, it can't take 4. 1, 2, 3.
Okay. So 0 to 1 and 1 to 3, correct?
Yeah, yeah. Okay, so there is it.
Even 12th is wrong, I think.
Hello, sir, but it should be sir 0. So y cannot take 4 value, right?
No, it will be up to 3 then, I think.
No, I don't think.
Yeah,
so.
maximum is 3.
It should
We
be
can
0.
ignore 3 to 4. No, we
Yeah,
can
3
ignore
from 3 to
4.
4 is 0. One thing, and this
We are finding at a value 1, 4 of this joint density function.
and one more thing, we are calculating here CDF, right? This is not PDF.
Okay.
This is not marginal.
No, this is marginal, but we are calculating the CDF value, not the PDF. PDF, okay, but then also, okay, I need to check once again. Yeah, but 0.5 would be the correct one for this. I guess the 11th, 12th is some mistake, I guess.
So is 12th correct? Because I'm
12th
getting
is also 0.5.
0.5. Na? Okay.
Yeah.
I'm also getting that. Yeah.
Okay, then this has been submitted, right? That we
Yeah,
need to,
but
This
it's
is
coming as
complete and-
wrong.
okay, this we have to, I'll exclude this questions then. Check it
Okay.
once.
13 actually, is it a marginal or like how do we calculate marginal for both?
More, this is not marginal, this is the joint one because XY both has been given, right?
Okay.
Yeah, it's a mistake. Okay, and anyway, like anywhere else, is there any mistake? Like, okay, yeah.
I think this is done based on the tutorial method.
Yes, sir. It is based on the tutorial that these answers are coming.
Hmm. Okay. Anything else from like 11th or 12th or any of the weeks? Okay, this we have to correct it.
So from week 9 to 12, we'll expect about 40% weightage of the marks.
Yeah, there will be like from each of the weeks you can expect 5 marks of questions. If this exam, just assume this as a 50 marks of exam, so you'll expect 5 marks of question from each week.
Okay.
So 20 marks is around 40%, right? It's 40 to 45 sort of things.
Okay, right.
Okay, yeah. Anything else? You can ask regarding the last week or the second last. We'll be having the, what you can say, the revision session also. Maybe one will be on this Saturday. So revision session, do attend everyone. Anything else, like anywhere, if you're having any other issues? There won't be any mock for the final also. Somebody is asking if there will be mock. There won't be any mock for the final. So if you don't have any, so should I close this or yeah? So there won't be any mock for the final exam.
Just one general question, sir. This notation for marginal and CDF is the same, that capital F.
Yeah, that is why everyone got confused, right?
But actually, what is the notation for marginal? Is it? It should be small f.
No, it can't be small f. It's a capital F only.
Okay.
But if you have been given only like X, then it's a marginal, right?
Both, then it's a joint, right? So that's what I thought. It should be small f. But if you're given only one variable, then it's marginal. Otherwise, capital F is only for CDF.
Yeah, it's a CDF regarding the X, like marginal. It's asking regarding the marginal of X. Okay, but see how generally we write the CDF. Like if they've been asked regarding the PDF, they would have written F as small, right?
Right.
Yeah, there will be a formula set in the final exam. Okay, thank you. So nobody has any other issues, right? Which
Thank
week
you,
is
sir.
like for the final you should concentrate in all the weeks. Like mostly from 5 to 12, because from 1 to 4 there is very less question and those are pretty simple also. I'm not aware of that, like the cutoff date for that mark. Okay, yeah, somebody has told 23rd of March. So you can solve by tomorrow. Okay. So everybody, so should I close this session? Who was asking regarding that 11th week, that graded assignment thing? Are you there or have you left?
Sir, you were saying something?
Yeah. So I was asking, like, whoever was asking regarding the 11th week, has she left or is there?
No, sir. My doubt was not related to 11th week.
Okay, so what you were asking? You were asking regarding something, right?
Yes, sir. Sir, I was asking regarding the cutoff